start by solving an absolute value equation. Keep in mind what absolute value represents. The absolute value represents the distance away a point is from zero. Absolute value is always zero or a positive value. So when we're solving an absolute value, the first thing we do is isolate the absolute value expression. So in this case, it's already isolated, and make sure it's equal to a value that is greater than or equal to 0, and it is in this case. So now to solve, we have two solutions. So we're going to set the first as 5x plus 20 over 4 equals 5, because the number 5 is 5 units away from 0. And we also set 5x plus 20 over 4 equals negative 5, because negative 5 is also 5 units away from 0. So now we're going to solve. So what I do is I always put my binomials inside parentheses. That's not required. And then I'll clear the fraction. So I'll multiply both sides by the least common denominator, which is 4. So what that does is reduces the denominator and eliminates it and makes it 5x plus 20 equals 20, much easier problem to solve. And then I'm going to isolate my variable and solve. So I have 5x equals 0, and 0 over 5, of course, is 0. I'm going to do the same on the second equation. I'm going to clear the fraction by multiplying both sides by the LCD. That would leave me 5x plus 20 equals negative 20. Then again, you want to isolate your variable. So 5x would equal negative 40, and I'd divide by 5, so x would equal negative 8. So my next equation, I have two absolute values. I have the absolute value of 1/2 x plus 2 equals the absolute value of 3/4 x minus 2. We approach the problem the exact same way. So I'll set 1/2 x plus 2 equal to 3/4 x minus 2. And then I'll work it out a second time as 1/2 x plus 2 equals the opposite. So this becomes negative 3/4 x plus 2. So I took the opposite of both of the terms of the second equation. Okay, so now, as I did before, I'm going to clear my fraction by multiplying by the LCD, which would be 4. So I multiply every term by 4. So in the first term, 2 goes into 4 2 times, so this would leave me a 2x. In the second, I multiply 4 times 2, and that gives me 8. The next, the 4's reduce, just leaving me with a 3x. And here I have negative 2 times 4, which is a negative 8. So again, I'm solving for x, so I'm going to move the x's on the left-hand side and the constants on the right. So this 2x minus 3x is negative 1x. And negative 8 is negative 16. So I divide both sides by negative 1. So x would equal positive 16. That's one solution. So I'm going to do the same for the other. So I'm going to multiply by the LCD, which is 4. The 2's reduce. So 2 times 1 is 2x. 4 times 2 is 8. The 4's reduce, leaving me with negative 3x. Plus 2 times 4 is 8. So I'm going to do the same thing. I'm going to move the x's on the left-hand side. So I'm going to add 3x to both sides. Then I'm going to get rid of the constant on the left-hand side. So I'm going to subtract 8 from both sides. 2 plus 3 is 5x. And 8 minus 8 is 0. So then I'm going to divide both sides by 5. So my second solution would be x equals 0. Next, we're going to talk about solving radical equations. So anytime I'm solving a radical equation, here I have the square root of 2x plus 11 equals x plus 7, I want to isolate the radical. So I'm going to subtract 11 from both sides. So this leaves me with the square root of 2x equals x minus 4. Okay, so I need to eliminate the radical sign. In order to do that, since this is square root, I need to square both sides. Notice I'm putting the x minus 4 in parentheses. I'm not squaring each term individually. I'm squaring the entire right side. So on the left-hand side, that removes the radical sign. Now on the right-hand side, I have x, the quantity x minus 4 squared. So I have x minus 4 in parentheses, and I'm squaring that. I don't square the x and 4. What that means to do is to multiply x minus 4 times itself. So now you're going to use the distributive property or the FOIL method. And you get x squared minus 8x plus 16. Next, I need to set this equal to 0 because I have a quadratic equation. So it's best if you move the 2x to the right-hand side because our x squared is positive. It just makes it easier. So that gives me 0 equals x squared minus 10x plus 16. Okay, so now you have a 1x squared. So that means you can use the shortcut. You don't have to do that AC method. So we're looking for the factors of positive 16. So what multiplies to give us a positive 16? So if it's positive, our signs have to be the same, and adds to a negative 10. So we know that x minus 8 times x minus 2 would be our two factors, because negative 8 times negative 2 is a positive 16, and negative 8 plus negative 2 is negative 10. Now I set each one of these to 0. So one of my possible solutions is x equals 8, and the other would be x equals positive 2. We need to check our answer to make sure that these work. So I'll start with the 8. So I have the square root of 2 times 8 plus 11 equals 8 plus 7. So 2 times 8 is 16. So we have the square root of 16 plus 11 equals 15, because 8 plus 7 is 15. The square root of 16 is 4, and 4 plus 11 is 15. So my answer checks. So 8 is a solution. Now I have to do the same thing for 2. So I'm going to plug 2 in. So I'd have the square root of 2 times 2 plus 11 equals 2 plus 7. So the square root of 2 times 2 would be the square root of 4 plus 11 equals 9. We know the square root of 4 is 2. And 2 plus 11 is 13, and 13 does not equal 9. Therefore, 2 is an extraneous solution. So our only solution to this problem is x equals 8. Always check your answers. Okay, now we're going to solve a problem with a rational exponent. So here we have the quantity 2x plus 2 raised to the 1/2 power equals 2. So what we need to do is get rid of that rational exponent by raising both sides to the reciprocal of that. So again, we have 2x plus 2 raised to the 1/2 power equals 2. So in order to make this 2x plus 2 to the first power, not the 1/2, we need to raise it to its reciprocal, which is 2 over 1 or 2. So we're going to raise both sides to the second power. Now on the left-hand side, see what happens? This reduces, and that gives us 2x plus 2 to the first power, which is just 2x plus 2, and that would equal 2 to the second power, which is 4. And now I solve. So I'm going to subtract 2 from both sides. So 2x would equal 2. Divide both sides by 2. So my solution would be x equals 1. This next problem says solve the equation by making an appropriate substitution. So in its current form, there's two different ways you could go about it. I'm going to go ahead and go by what they're asking in the instructions and to use substitution. So you notice this isn't familiar because we have the quantity x minus 2 squared plus 2 times x minus 2 minus 24 equals 0. So what I want to do is substitute something in for that x minus 2 because both the first term and the middle term have that as a factor. So I'm going to make a equal x minus 2. So the reason I'm going to do that is I'm going to make this so it's quadratic and easier to solve. So in place of x minus 2, I'm going to put a. So instead of this being x minus 2 squared, this becomes a squared. And the middle term, instead of it being 2 times x minus 2, it's just going to become 2a for the time being. And we still have our minus 24 equals 0. So again, my leading coefficient is 1, so I can use a shortcut to factor. Now this is much easier to factor. So I'm going to look for the factors of negative 24 that add to it positive 2. So that would be a plus 6 and a minus 4. Because 6 minus 4 is positive 2, and positive 6 times negative 4 is negative 24. So I'm going to finish by solving. So I'm going to say let a plus 6 equals 0, and let a minus 4 equals 0. So I subtract 6 from both sides. A equals negative 6. I'm going to add 4 to both sides. And so a equals 4. Well, a wasn't a part of our original problem. So to finish this, I'm going to substitute the x minus 2 in for a. So instead of this being a, it's going to be x minus 2. And now I'm going to finish solving. So I'm going to add 2 to both sides. So x would equal negative 4. I'm going to add 2 to both sides. And then x would equal 6. So I have two solutions, negative 4 and 6. We use substitution, so again, we can write it into the form of a quadratic equation, which is much easier for us to factor and solve. Now let's look at some rational equations. So we have fractions in an equation. So again, what we want to do is clear the fraction. So what I'm going to do is put parentheses around the x minus 9s. And next, I'm going to multiply each term by my common denominator, which is x minus 9. So in my first term, the x minus 9s reduce to 1. So that leaves me 12. Plus, I have 3 times x minus 9 equals, and the x minus 9s reduce to equal 6. Now I'm going to distribute. Combine like terms. So I have 3x, and 12 minus 27 is negative 15. And then I'm going to add 15 to both sides. So 3x would equal 21, and then divide by 3. So x would equal 7. Remember, you need to check your answer. Especially make sure that your answer doesn't make your denominator 0. So since our original denominator is x minus 9, we know that our answer cannot equal 9, or it would make our denominator 0 and our fractions undefined. So please make sure, at least if you're not going to plug the 7 into the x and check this problem, make sure that your answer doesn't make your denominator 0. Our next problem, we have x plus 8 over x squared plus 9x plus 20 minus 8 over x squared plus 8x plus 16 equals x minus 8 over x squared plus 9x plus 20. So the first thing that you want to do is put parentheses around the binomials, and then we're going to factor the denominators. So again, since our leading coefficients are 1, so I'm going to factor x squared plus 9x plus 20 by asking, what are the factors of positive 20 that add to 9? And that would be a positive 5 and a positive 4. So for the second term, I'm looking for the factors of 16 that add to an 8, and that would be a positive 4 and a positive 4. And for my last one, it's exactly the same as the first, so I can just write down my answer, x plus 5 times x plus 4. Okay. One other thing that I would recommend, anytime I have a subtraction problem, in order to keep the signs straight, I change subtraction to adding the opposite. So instead of having minus 8 over x plus 4 times x plus 4, I change this to an addition problem, and I change the 8 to an opposite, or a negative 8. So my next step is to multiply every term by the common denominator. In this case, the common denominator, or LCD, is going to be x plus 4, x plus 5, and x plus 4. Because the second term has 2 factors of x plus 4, 2 factors of x plus 4 have to be a part of the LCD. So I'm going to take the x plus 8 over the x plus 5 times x plus 4 and multiply it by our LCD, which is x plus 5, x plus 4, and x plus 4. So plus, I'm going to have negative 8 over x plus 4 times x plus 4. I'm going to multiply that times our LCD, x plus 5 times x plus 4 times x plus 4. And that's going to equal our x minus 8 over x plus 5 times x plus 4 times our LCD, which is x plus 5 times x plus 4 times x plus 4. Now you're going to reduce. So for the first, the x plus 5s reduce, and one of the x plus 4s reduce, and that leaves you with x plus 8 times x plus 4. For the second, the x plus 4s reduce, and that leaves us plus negative 8 times x plus 5. That's going to equal, now on the right-hand side of the equal sign, the x plus 5s reduce, and one of the x plus 4s reduce, and that would leave us x minus 8 times x plus 4. Now we have to use the distributive property, or the FOIL method. So when we multiply x plus 8 times x plus 4, we get x squared plus 4x plus 8x plus 32. Now we're going to distribute the negative 8 times x plus 5. So that becomes negative 8x minus 40. And on the right-hand side, we're going to use the distributive property or the FOIL method. That's going to give us x squared plus 4x minus 8x minus 32. So next, let's collect like terms on each side individually. So there's only 1x squared on the left-hand side. Now I'm adding 4x plus 8x, which is 12x, minus 8x is 4x. So again, positive 4 plus 8 is 12, minus 8 is 4. And then we have 32 minus 40, which is negative 8. On the right-hand side, we have x squared. Positive 4 minus 8 is negative 4x, and we have minus 32. So now, since we have quadratic, we initially want to set it equal to 0. But when we start by moving the x squared on the right-hand side to the left-hand side, the x squareds are eliminated. So we have a linear equation left. So what we want to do is isolate our variable. So what we're going to do is add 4x to both sides and add 8 to both sides. So 4x and 4x are 8x. The negative 8 and positive 8 reduce. The negative 4x and positive 4x reduce. And negative 32 plus 8 is negative 24. We're going to divide both sides by 8, and x equals negative 3. So keep in mind, you want to make sure the negative 3 doesn't make our denominator 0. So x plus 5, x plus 4 is our denominator, so negative 3 wouldn't make our denominator 0. So we'd be okay.